area. In this lesson, we will learn to calculate the area of compound figures containing sectors of circles. Also solve problems related to area of compound figures containing sectors of circles. So at the end of the lesson, we will be able to find the area of compound figures such as this. The figure 1 is a Norman window. As you see here, the Norman window, a half a circle, is set on a rectangle base. So this is a compound figure containing a sector of a circle, because half a circle is a sector. And figure 2, now if you want to find the area of the shaded region, as you see, this figure is coming from an intersection of two sectors of circles. And figure 3, so this is a compound figure containing sectors, because four sectors are attached to a square of side 14 centimeters. So at the end of this lesson, we will be able to find the area of such diagrams or figures. Prerequisite: the things that we're supposed to know before we begin this lesson, or things that we learned in our previous classes. So we're supposed to know the area of these figures that we see over here. This is a rectangle, a triangle, a circle, parallelogram, and a trapezoidal. Let's see if we can really remember those formulas first. Now, this is a rectangle of length L and the breadth of B. So the area of a rectangle of length L and the breadth B is simply the length times the breadth. Area of a triangle of base B and altitude h is 1/2 base times the height. So this area of the triangle is 1/2 base times the height. Area of a circle of radius r is 5r squared. So a is equal to 5r squared. Area of a parallelogram of base B and altitude h is simply b times h. So this area is b times h, or bh. So area of a trapezoidal of two parallel side length a and b, and the altitude of h is 1/2 the sum of two parallel sides times the altitude. Sector of a circle and area of the sector. And if you can remember, when you in our lesson perimeter, we talk about sector of a circle. Just to recall again, the sector of a circle is a part of a circle containing two radii and the intercepted arc. So this is a sector of a circle. Now in this lesson, we are interested in knowing the area of this sector. So this angle over here is the most important thing right now. It's called angle at the center. And we are interested in the area of this sector. So that we are interested in the area of the sector. Now, if you look at, here is a sector of a circle, and this is the center, and the distance from center to any part in the circumference is a radius. And this is the angle over here, that is the angle at the center. Angle at the center. And now this angle, if I go all around, if I go around it, it's called angle around the center. It's called angle around center. Now angle around the center is always 360 degrees. Now what you see over here is, if I increase the angle at the center, the area of the center also increases. So if I increase the angle at the center, you can see the area increases. That means the area is directly proportional to angle at center, angle at the center. Now we just want to know exact relationship between these two. Let's complete this table. So at the end, we will be able to figure out the area of a sector and the corresponding angle at the center. Now if you look at the first diagram, which is a half a circle, so we want to write down angle at the center first, and then angle at the center as a fraction of angle around the center, and then area of the sector as a fraction of the area of the circle, and at last area of the sector. Now the first one, so this is a half a circle, so the angle at the center is 180 degree because it is a straight angle. So this is the angle at the center. This is the straight angle, which is 180 degrees, and the angle at the center as a fraction of angle around the center. So angle at the center is 180, angle around the center is always 360. So clearly that is equal to 1/2. And the area of the sector as a fraction of the area of the circle. Now clearly in the diagram, the area of this half a circle is 1/2 of the area of the corresponding circle, and therefore the area of the sector is 1/2 of the area of the circle, which is 5r square. So this is a quarter circle, so therefore the angle at the center is 90 degree. So angle at the center as a fraction of angle around the center, so 90 over 360 is 1/4. Now clearly the area of this sector is 1/4 of the area of the corresponding whole circle, and therefore the area of this sector is 1/4 of the area of the whole circle, which is 5r square, 1/4 of 5r square. Now in this sector, the angle at the center is 45. Therefore angle at the center as a fraction of angle around the center is 45 over 360, which is 1/8. Clearly the area of this sector is 1/8 of the area of the corresponding circle. Now if you see that this is 45 for 90 degree, for a 1/4 you can put two sectors like this. So there are two sectors for each quarter, so that will be 8 of them. So therefore the area of the sector as a fraction of the area of the whole circle is 1/8. Therefore the area of this sector is 1/8 of the area of the corresponding circle, which is 5r square. Now for a sector of angle at the center of theta, therefore angle at the center as a fraction of angle around the center is theta over 360. Now if you notice these two columns, they get the same values. 1/2 is equal to 1/2, 1/4 equal to 1/4, and 1/8 equal to 1/8. That means angle at the center as a fraction of angle around the center is same as the area of that sector as a fraction of the area of the circle. Therefore, we will get the same relationship over here. So we have 1/2 is equal to 1/2, 1/4 is 1/4, 1/8 equal to 1/8, and therefore this has to be theta over 360, and that gives us the area of the sector theta over 360 times 5r square. We found that the area of the sector as a fraction of area of the circle is same as angle at the center as a fraction of angle around the center. So in this sector that we are interested in, area of the sector is A. So area of the circle is 5r square is equal to angle at the center, which is theta, over angle around the center, which is 360. Now since we want to find A, let's multiply both sides by 5r square. So you multiply both sides by 5r square. Now clearly that gives us area is theta over 360 times the area of a circle 5r square. So this is a formula for the area of a sector. So we can use that to find the area of a sector and also solve related problems. Now let's do this to example problem to see how we apply the formula we got for the area of a sector. And example 1, we have to find the area of the sector given that angle at the center is 120 and radius is 21. And we know our formula in the area formula for sector, if you know angle at the center and the radius, we can find it. So the area of a sector is given by angle at the center over 360 times the area of the whole circle, which is 5r square. So therefore the area is equal to theta is 120 over 360 times 5. We use 22 over 7 times the r squared. The r is given as 21, so you get a 21 square or 21 times 20. Now 120 is a factor of 360, so 120 times 3, and 3 times 7 is 21, so that will cancel one of the 21s. So at last we'll have 22 times 21, 22 times 21 square centimeters, so which is actually equal to 462 square centimeters. In this example, in the sector, angle at the center is theta and the radius is 6 centimeters, and the area is given as 88 over 7 square centimeters, and we want to find the angle at the center. So again, if we start with this formula, since we know the area and the radius, so we can find theta. A is equal to 88 over 7. Theta we want to find over 360 times 5, which is we use 22 over 7. R is 6. So you get a 6 squared, or 6 times 6. So clearly this, you can divide both sides by 7. And then 22 is a factor of 88. 22 times 4 is 88. And then as you see here, 6 squared is 36. That cancels with 360. 36 times 10. So we have now the left hand side we have 4. The right hand side we have theta over 10. Now if you multiply both sides by 10, then we'll get the 40. Theta is going to be equal to 40 degrees.